Thank you. So perceiving sound or sound perception is an almost constant task that all of us have to do all throughout our day. Just like our eyes, our ears have to work overtime to allow us to organize our perceptual environment. And given a particularly noisy environment, this can be a pretty difficult task. And despite this fact, most of us would think that our auditory system is a well-oiled machine that's able to help us organize our environment and make relatively few errors. However, it turns out that pretty often the opposite is true, and that there are some pretty significant limitations to our auditory system, which can lead to us missing substantial changes in our environment. And when this happens, we call this change deafness. Change deafness. Because the listener is thought to be deaf to a change. And so there's been a whole host of research that's been carried out to be able to understand what's causing this perceptual error, what sort of factors are leading to this. And the answer is, so far, we don't really know. So there's no real group of factors or a nice model that can help us account for our data at this point. And I think one of the reasons why that is that we have yet to use a measurement technique that has gone to the real crux of the issue or that caused the issue, which is, are listeners getting all the details out of the sound they're trying to hear from the very beginning? And so there's this really neat measurement tool where we can actually extract exactly what listeners are hearing just by recording their brain activity. So if we record the brain activity from someone's brainstem, we're able to pick up on exactly all the acoustic features that they're trying to process. And the way this is possible is that when the brainstem is passing that information on, the actual rate that it's transferring it, that structure actually starts to take on the structure of the sound that they're processing. So if you were to compare the two, the brainstem response with the physical stimulus, they would look very similar. And more importantly, the degree to which they look different can also tell you what the person is missing when they're trying to listen to a sound. So on the left-hand side here, I have a physical representation of a speech syllable, a DA syllable, and on the right-hand side, I have a representation of someone's brainstem response when they were trying to listen to this DA syllable. And so what you can see is there's definitely some overlap between the two. However, more importantly, you can see what that person was missing. And so this measurement technique gives us a really neat opportunity to really get at the crux of what's causing change deafness. Is this happening lower level in your brainstem, or is this happening where down the line in a higher level cortical area? And so once we figure out what the true cause of this perceptual error is, we can make targeted training programs to be able to improve the perceptual ability of our listeners. And so there are a number of professions that would benefit from this. For instance, our law enforcement personnel or military personnel, if they were to make a perceptual error during their line of duty, this could lead to some pretty significant dangers. And so studying change deafness provides a really nice way to be able to improve their daily lives and also, of course, improve people like us, our daily lives as well. But thank you for listening.